Hello, class. Welcome to lecture 7.2. Today we're going to be doing the budget constraint and then after that starting to introduce the idea of this optimal bundle given your constraints and utility. So the reading for this week is pages 74 to 77. And so I just want to motivate this real quick with saying the key to economics is scarcity. And this is formalized in the constraints that we're going to be talking about today, specifically a budget constraint. And scarcity, we know, leads to the necessity of trade-offs because we can't have all of our unlimited wants and needs given limited resources. So to characterize consumption possibilities, we use a budget constraint. And these constraints are super important for theory because they make attempts to maximize happiness, i.e. to get an indifference curve as close as possible to infinity realistic. And this assumes people do not have unlimited money and or time and or other constraints. And we'll later use for firm problems too. And so with these things, a utility and a constraint, we can solve for the optimal utility maximizing bundle, which is exciting. And as economists, we're going to often ask the question, but what's the trade-off? And these trade-offs are necessary due to constraints. And one area where asking what the trade-off might be is like, what is the trade-offs to allowing people to mail in votes for the election? So on one hand, if you allow mailing in votes, then the total number of fraudulent votes might increase, but a benefit to allowing that would be less health, and so you have to think about how you trade those two things off. So anyway, our budget constraint is going to assume no borrowing or saving, helping us simplify the problem. It alternatively assumes something like inflation is sufficiently high to wipe out any money you save in the next period. So we're going to assume that you spend money on two goods, again, helping the problem be the most tractable. And we're going to have a consumer who has a fixed amount and they spend all of that on two goods. A consumer buying more of either good does not affect prices because we're going to assume that the prices are set in the market and that the consumer is relatively small compared to the market. And this makes our budget constraint linear because the prices, more specifically the price ratio, doesn't change based on what the consumer decides. It's always a constant price set in the market, a competitive market. And this again helps us simplify. So how we're going to write our budget constraint is down here at the bottom where we have income equals price of good one times the number of good one that you buy plus price of good two times the number of good two that you buy. And we're going to use Y for income. So if you see Y anywhere, that just means income. And so this is a depiction of a budget constraint. And so you should take heart in this because it's just a straight line. And you should have seen straight lines in a math class by now. And we can write down the equation of this line as Q2 equals income over P2, this point minus the slope, which is kind of this, by solving for Q2 in the budget constraint, which is what I do right here. And so yeah, you can just define Q2 in terms of income and prices in good one. And so Y, P1, and P2 are all constant numbers and they're parameters outside the control of the person, which we're just not going to allow income to be determined in the model because it makes it very difficult, but it's not impossible. And so anyway, the consumer chooses Q1 and Q2 to maximize their happiness. These are called choice variables. So they choose, and the budget constraint can be expressed in slope-intercept form. So it's just a straight line because we know that the amount of consumer buys does not alter the prices. And so you should think about, a good way to think about these are in terms of this intercept right here. So the number of units you can get of good two equals the total amount of income that you have divided by the price of good two. So that's just like if you spend all your money on good two, how much can you have? And that's going to be the y-intercept right there. And so we know that this P1 over P2 price ratio does not change with with whatever part of the budget constraint you're on. And so I'm going to show you kind of the shortcut way to do this. is to just solve for the intercepts. And so we know the intercepts that Q1 is equal to 0. And so this term drops out, this P1 times Q1, and you have Y equals P2 divided by Q2, and that's where Q2 equals Y over P2, income divided by the prices of good 2. And like I said earlier, that's the max amount you can get if you spend all your money on good 2. And so this is what that looks like. We just solve for Y over P2 in this budget constraint. And then we can do the same thing with the x-intercept by assuming that Q2, this good, is 0, and then solving out the budget constraint again. So this is 0. We just have left over with Y equals P1 times Q1, and Q1 equals Y over P1. So income divided by the price of 1 is if you spend all your money on good 1, how much can you have? And that's just this x-intercept here. And so I'm going to give you a more specific example of that. Let's say that we have your income equals the price of good 1 plus price of good 2 times the amount of good 2. And we have 2 goods, exogenous income and prices, like I mentioned, and the quantities we're going to choose. And so good 1 equals coffee, good 2 is video games, the price of coffee is 5, the price of video games is 10, and income I changed to 200. And so 5 times the price of coffee times plus 10 times the price of quantity of video games. And so now we have, this is all we need to graph the budget constraint in our Q1, Q2 space. So we know that any 2 points define the budget constraint, and this is our budget constraint. So we're going to start by solving for the QV intercept. And so the QV intercept is just income divided by the price of video games, or plugging in our numbers here, we get QV equals 20 if we buy no coffee. So we can buy 20 video games if we spend all of our $200 only on $10 video games. And this is our first point on the budget constraint, is 0, 20. And then we're going to do the quantity of coffee intercept on the x-axis. So if we spend all of our $200 on coffee, then and the price of coffee is $5, then we know we can buy 40 cups of coffee. The max amount of coffee you can buy is 40 units if all of the money is spent on coffee. And this is our second point on the budget constraint. So because we're assuming that prices are set in the market and that the amount you buy does not change the slope of the line, then we know that this is going to be a straight line between these 2 points, and we just draw a straight line between them like so. So it's quantity 2 equals 20 minus 1/2 quantity 1. So the amount of video games, good 2, equals 20 if you buy 0 coffee. And for every additional coffee you buy, it costs you 1/2 of video games, and an additional video game costs you 2 coffees. And so that's the price ratio. That's the trade-off between goods, that if you spend additional money on coffee, then you have less video games, and you have less video games, you spend more money on coffee. And this 1/2 to this price ratio between them, the marginal rate of transformation, as we will see, is the important part about it. It's the slope of this line. And so for the consumers optimal bundle, we know that they want the highest possible indifference curve or utility subject to this budget constraint, given that they can't consume any goods out here. This is their set of potential bundles that they are considering, and they want the highest indifference curve from these bundles. And the highest indifference curve will be the farthest out. And so what they're going to do is they're going to choose Q1 and Q2 subject to these parameters to maximize this utility. And the semicolon is used because P1 through Y are not chosen. They're just given in the model. And so what that looks like in a figure is, this is a budget constraint, is this negative linear line right here. And we know that the max donuts you can get if you spend all that money on donuts is 120. And if you spend all your money on books, then you have 10 books and no donuts. And so we can use a slope formula to find out that the slope is -12. That is, if you want an additional book, you give up 12 donuts, and that's just trade-off that the market sets due to scarcity. And so the next important part about this that we've been covering are these utility indifference curves that show, they're again called indifference curves because you get an equal amount of happiness at every bundle on one of these on these indifference curves. And so we know that this UH is the best, it's the farthest away from zero. So you're the most happy on this UH, you're the middle most happy on this UM, and your utility is the lowest on UL. And so given that all these bundles are goods are beyond the budget constraint, it's not possible to obtain the high utility indifference curve. But a bundle that is possible with the indifference curve with the budget constraint is this point B, and that's where the slope of the indifference curve equals the slope of the budget constraint, aka where their tangent. And so we know that this is the highest possible indifference curve that an individual can reach given their preferences and prices and their income. And you can see that these points on UL are inferior to UM. We know that UM is farther out. And this G point and H point, these are both possible, but they're on lower indifference curves than UM. So this bundle of goods is more preferred than either G or H. And so B is optimal. And so the math behind there is we say that there's an interior solution when the difference curve is tangent to a budget constraint, and you don't consume zero of either goods. Otherwise, it would be a corner solution, which I'm not going to get too much into. And then a tangent point, no higher bundles or higher utility are possible. At this point, the slope of the budget constraint, like I said, which we are calling the marginal rate of transformation, equals the slopes indifference curve, which I have shown you in previous lectures, how that is the marginal rate of substitution. That's the mental trade-off between staying on the same indifference curve or utility level, getting more of one good and giving up another. So we said this optimal point is where the slope of the budget line, how possible it is to trade off one good for another, equals the mental trade-off between one good for another, or the marginal rate of substitution. And so another way to simplify these this is the marginal rate of substitution here, the marginal utility of good 1 over the marginal utility of good 2. The negative ratio of that equals the price ratio of those two goods. And so after some simplification, you can get U1 over P1 equals U2 over P2, and it says the marginal utility of pizza equals the marginal utility of pizza divided by the price of pizza equals the marginal utility of burritos divided by the price of burritos. And so its utility is maximized if the last dollar spent on pizza gets the same utility as the last dollar spent on burritos. If last dollar spent on burritos got more utility than pizza, more burritos would yield higher utility. And so this is another way that you can conceptualize what the optimality condition is that it's just the utility given, the marginal utility given a price of equals the marginal utility of the other good divided by a price. And so at point B, like we said is optimal, the marginal rate of substitution, the slope of the indifference curve equals the marginal rate of transformation, which is the slope of the budget constraint. And we know that because these two are tangent only at point B. And so just the interpretation is that highest happiness possible touches the budget constraint. The greatest utility obtainable given income and prices is point B, and there's no other point beyond B that will give you a higher level of utility, because this is the one place where this indifference curve touches the budget constraint, and no other higher curves would be touching the budget constraint at any point. And so all the other utility curves would have goods that are not obtainable given somebody's income and the prices set by the market. And so, yeah, this is the other side. So we've done utility, and now I've shown you the budget constraint. And so we can now solve for this consumer's optimal bundle. And I will show you how to do that using calculus in the next week. for now, I hope you all enjoy your fall break, and thanks for listening.